Welcome on this wonderful day to my pick of the week of IT-related topics. In these videos you will find knowledge and noteworthy things for developers and IT architects in regular intervals. It's about new discoveries, it's also about hype topics, as well as oldies but goldies. I've been fascinated by these topics for more than 30 years up to now, and I really hope I can show you some things which might be interesting for you as well. I wish you all a lot of fun in the next few minutes. So let's go. I had promised to share the first benchmarks results with you, and here we are. I want to do this now, and I tell you the results of the speedometer 3.0 test. What you see here are the photos of my test machines. And the top left you can see my work device, a Dell Latitude 7730 with an i5 processor. Admittedly, this is not a real developer computer, but as a comparison machine it serves its purpose. Then to the top right, the new Surface Laptop Copilot Plus PC, what a name. At the bottom right, my really old Intel NUC from 2015, I love it, with an i3 5th generation processor. In the middle bottom, my Dell Latitude 5580 from 2018, running Linux on it. It has an i7 8th generation processor. In the top bottom left, for comparison, a MacBook Pro from 2019 with a Core i9 processor. And what is not shown here is my desktop PC from 2020 with an i5 of the 10th generation. So overall a lot of Intel machines, and I will also use these computers again in future comparisons. So first now to my results of the speedometer 3.0 tests. To be honest, I think it's rather interesting to see how other Windows machines compared to this new generation instead of MacBooks, because I think most of us won't change the operating system just for the other processor. So what you see is the first run of speedometer 3.0, and here are the results. What you can see here is the average result after 10 runs on each machine, and I think it's not a big surprise. So what we see here is that as this is mostly a single core speed test, we see that over the generations of the Intel machines and now with the new Snapdragon machine, we see that it really speeds up over the years. So if we say we took this oldest machine, so my 2015 NUC machine with an i3 processor, we have 7 times the speed now on the new Snapdragon Elite 12-core machine. So this is overall, I think, a good result for the new machine, and especially when you compare it to the newest machine here, so with the Dell Latitude 7330 from 2022. And I think this really shows that this machine is really, it's fast enough, just to say so. It's fair to say that it's just fast enough for a new modern machine. So, okay, we see this machine is fast enough, and of course we will make some more comparisons later on, but the most important question for me is always, what about the software side? So what can we expect from this machine? And let's try to find out. So I think one of the most important things for me on a Windows machine is what is wslg doing on that machine. So let's start and find out how we can use wslg on this machine, how it works, and are there some limitations we need to know. So hello again. So in the first few minutes of this video I want to show you how wslg is running under this Windows 11 on ARM system. So let's start over. So what you have to do first is that you download a Linux distribution, just the one you would like to have. So I normally use Ubuntu on these systems, and as you can see, so sorry for this is the German version, but nevertheless you can just use Ubuntu. I stay with Ubuntu the long time support version, so 24.04 currently. And you can install it just from within the store, and afterwards you can just start it from here. You may see an error which indicates that you have to install the wslg feature. So you need to go to the system settings and looking for Windows features, and then please install the WSL feature. After that, you may or you have to reboot the system, but that's all. So after that, you can just start Ubuntu. What I recommend is using the terminal application. So I always use this Windows Terminal Preview version here. I installed both of it, and afterwards you can just see that it looks like this, and you should have an entry here which indicates that Ubuntu is installed and that you can just start it. And another thing I want to check is if the wslg stuff is also working. So this is the possibility to execute X11 applications under WSL2. So to do that and to check that, you have to install something like an X11 application, just like X-Eyes. What you need to do is installing the X11 apps. So this can be done by sudo apt install X11 apps. And I'm doing it here. And after that, we have some X11 application installed. For example, the wonderful X-Eyes, and let's see if it works. And yes, here we are, fantastic. Okay, and this is how it looks like. So what we want to see is if the installation is really natively compiled for ARM. And a simple way to do so is, we can just write a very simple program. As I did here before, what you can see here is this little C program, nothing important. If you compile it, I will just do it again here for you. So we just compiled it now, and of course we can execute it. But what is more important is we analyze this program, and now we see that it's really an ARM application what we built here. So perfectly. So the installation here is really an Ubuntu running on ARM processors and running natively here on this machine. As a next step, I want to make a first performance test. And what I want to do is I install the Redis database, so this caching database system. I just download it from source, and then I'm just compiling it and running the test suite. So we can just find out how fast is this in comparison to my other Linux installations here. Okay, let's go to the site and download the application itself. So we can just use for Redis installation from source. And here we are, install Redis from source. And we just go here. I will do a simple temp folder. We just download it. We are just unpacking this Redis package. Now we have the Redis stable folder here. You might be in the position that you have to install the GNU compiler in the make tools and pgk-config. So this, of course, can always be done by sudo apt install etc and so on. And then you have to enter your password. But I already did this before, so I can just do a simple make, and let's see what comes out of it. It took about 15.5 seconds. And interestingly, the user time is higher than that. This is because of the parallel execution of the linkage of the application. I did the speed test a couple of times just to see if the heat, which is going up, of course, on that machine, has any influence on the average compile time. But after some runs, I just saw that the average time for compiling and linking the application was about 16 seconds. That was then stable after a while. And so I just took the time and went over to my other machines just to see how these works. And this is the comparison with my desktop PC with its Intel i5 10th generation processor. And what we see at the end is that it's about 170% faster on the Snapdragon machine, and especially when it comes to multi-core, it's even faster. So at the end, so what we find out for now is WSL2 is running quite good on that machine. The performance is really astonishing good, and well, let's see what comes next.